Okay, so we're going to move on to our next speaker guest. I think we're ready. We've got AAVE, Emilio.
Hello, everybody. Am I live? Yes, apparently.
Yes, Emilio, you are
Hey,
live.
John.
I'm giving you like an extra minute. How about that?
Oh, that's amazing.
So we're going to
That's
do a live
amazing.
coding session, I see.
What? Sorry?
We're going to do a live coding session.
Well, to be honest, I wanted to touch an argument that is maybe a little bit more complex. So there might be not much real coding live, like more showing how it works and like a little bit of code description, how it actually. I prepared an example for the guys with a small bounty. There is also a small bounty at the end of 0.2 ETH for people that wants to play with it, and the first one that will actually get the exercise right, they will get a small bounty. 30 minutes is a bit small of a timeline to actually talk what I want to talk about, but I think we are going to touch a really interesting argument. That is the flash loans. Everybody, I think, knows the flash loans. Is one very hot topic and is something that people wants to know about. Is maybe a little bit more advanced than what I said I saw before. About like before was a bit more like entry level. There is going to be an explanation of how flash loans work, how they work on chain. I will demonstrate how an actual flash loan transaction works, like by showing the actual execution of the transaction, and then I will show a little bit of code and give the guys reference if they want to take the challenge and win 0.2 ETH. So
Cool.
I think we can start.
Go for it. It's all yours.
Can you guys see my screen?
Yes.
Yeah, it's a little bit. Okay, let me show the. I have a short presentation first that prepared, like just to introduce the argument, the topic, and let's see. Do you guys see the presentation?
We have it?
We are ready to go, right?
Yes.
Oh, perfect. Okay, so flash loans. Everybody knows. I will go quite quick here because there is not much time. I'll just explain. Everybody probably heard about flash loans and what flash loans actually are. And it was introduced, like AAVE was not actually the first one, to be honest, introducing flash loan. The concept was lying around for quite a while, but nobody actually picked it up on them. What we did is actually integrate the concept of flash loan in a protocol that actually has a lot of liquidity available, which actually brought the feature to light for the whole DeFi space. What flash loans are essentially, we all know that transactions on Ethereum, they are atomic, right? So one transaction is either executed successfully in all its sub transactions, or it's reverted completely. So nothing is actually stored on the blockchain, right? So what flash loans actually do is they leverage this atomicity to allow anybody to take liquidity out of a smart contract with the condition that at the end of the transaction they return this liquidity, otherwise the transaction fails. Okay, this is the basic concept. Like people call them the Schrodinger loans, and that's because like the loan exists at the end of the transaction only if the transaction actually gets executed successfully. Otherwise, if the transaction fails, there is no loan essentially. So we have been with flash loans for 1 year and a little bit more than 1 year live. The protocol has issued like 2 billions of, actually 4 billions of flash loans, including also the new version of AAVE version 2. So I introduced it shortly and quickly the concept. We actually, with AAVE version 2 that was released like more or less 2 months ago, we extended the concept of flash loans with some very cool additional features that essentially allow a more broad use case for a flash loan within AAVE and also with other protocols. So how a flash loan actually works? We define essentially, we have a smart contract on Ethereum that is the AAVE protocol, main AAVE protocol smart contract that is called lending pool, right? Everybody that interacts with the AAVE protocol, they interact with this contract underneath. So this contract allows anybody to deposit funds, withdraw funds, borrow, repay, basic lending protocol functionalities, right? And this contract also exposes a function called flash loan, which is exactly what we are going to use to interact with to actually execute our first flash loan. Okay. So how flash loan? What is the architecture of a flash loan? So we have as I was saying, lending pool contract, which has also a flash loan function. People that interacts with flash loan, usually they call this function here, and this function receives as a parameter the address of another smart contract that is actually the smart contract that will execute the logic of the flash loan, that we call flash loan receiver. Okay, receiver because it's the actual smart contract that receives the funds when the transaction begins, right? So what happens is that we call this function here. This function automatically transfers the funds to this contract, that is the contract that we deploy, and is the contract that does the interaction with the protocol and uses the funds in whatever way we programmed it to use, right? And at the end of the execute operation, what happens is that the funds needs to be returned to the lending pool. How the funds are returned? It's actually the lending pool that will pull the funds from here. So the lending pool, if you guys are familiar with the concept of ERC20 approvals, what happens is that this contract approves the lending pool to essentially withdraw the funds from the lending pool receiver, from the flash loan receiver, that is actually the funds that we use for the operation to be complete and to be successful. Okay, so the architecture is quite simple. We have this interaction between two contracts. Of course, the execute operation at some point can become quite complex, depending on the operation that on the actual strategy that execute operation is gonna execute. So it might get complex or relatively complex. Can, for example, be a series of Uniswap swaps, and that would be, for example, trying to catch a slippage that there is between different pools in Uniswap and execute an arbitrage, right? Can be, for example, invoking a liquidation on Compound. So we get the funds from here and we liquidate on Compound without having actually any fund, or can be any other usage of funds that can be executed profitably in one transaction. This is more or less what flash loans are used for, okay? What can we build with using flash loan? We can build a lot of stuff. Right now, like maybe at the beginning it was not so clear. People like us, a lot of people associated flash loans with hacks, right, and abuses and arbitrages and stuff. Well, yeah, I mean they are used. There was a hack actually not long ago on Wayern, for example. It was not really a hack. It was more like an abuse of certain configuration and certain condition that. Essentially the abuser came out with some profit, right? So they abused a certain functionality over and over using flash loan. They actually used a couple of billions, I think, of flash loans within like 30 minutes, more or less, and they were able at the end of the day to end up with a profit of 2.5 million DAI. So. To be honest, like some people say it's a hack, some people say it's vulnerability, some people say it's an arbitrage. It really depends on how people sees this kind of actions on the blockchain, but they are essentially enabled by flash loans. Why flash loans? Because these are actually actions that usually require a lot of capital. And essentially, flash loans give capital for almost free, right? It's a small fee that you need to pay on AAVE. Some other protocols they have for free, like you will need to pay one way, for example, returning one way more. On AAVE, the fee is, I think, if I remember correctly, 9 BPS. So in Uniswap, it's 30 BPS, like a swap. So yeah. what you will need to do is use this capital as long as the transaction is profitable, the transaction will succeed. So I have prepared a live example, but before going to the live, honestly, it's a live example where I will show some code, but it's also an exercise that I will leave for you guys, and there is a prize at the end. Like I prepared a small contract that you can interact with using Flashloan in mainnet. I put like 0.2 ETH in it. There is a small attack, not so small actually, attack surface on this contract, and if you discover this attack surface, you can empty the strategy, the contract that I deployed using Flashloans. So if you guys want to play with it and you want to try to earn 0.2 ETH, then you can experiment a little bit and like extend the example that I will show you later, and like maybe you will win like 0.2 ETH. Like, try to do it while the gas cost is low, because otherwise you will end up like probably paying more in transaction cost than the 0.2 ETH. But it's still an interesting exercise for you guys. So, but before doing that, I wanted to show what actually a flash loan looks like in real life. Okay, so I can show, you can still see my screen, right?
Yes.
Anybody? Okay, perfect. Okay, I will show, for example, an actual flash loan transaction that is executed from our front end, okay, from our client interface. Let me see. If you go on AAVE, essentially, if you go on AAVE v2, we have added some functionalities. For example, you can borrow using a certain collateral, and then you can actually repay your debt. You don't need actually the principal that you are borrowing, but you can repay, for example, with the collateral. This is useful for people that leverages usually. So what happens is that people, for example, they deposit ETH, they borrow DAI, they buy more ETH, they deposit again in AAVE, they borrow more DAI, they buy more ETH, and that's a loop that is repeated until essentially you have no more borrowing power, right? This is leverage, okay? Essentially, people gets more exposure to ETH using this strategy. And usually they end up without any principal, like they don't have any DAI to, for example, if they use DAI to leverage ETH, they end up without any DAI to actually repay the debt. And what they do usually, if they want to take profit, or they want to exit the position because, for example, the price of ETH is going down, it's not profitable anymore to keep the leveraged position, they usually use the collateral itself to repay. How this works? How does this work? This works using Flashroom. Okay, so essentially the flow of the operation is the protocol, the client, the front end executes a flash loan. This flash loan uses flash borrows the amount that the user wants to repay in stablecoin. It repays the debt, which frees up the collateral. Then it takes the collateral, it withdraws from AAVE. It takes the collateral, goes on Uniswap, sells for the principal, and repays the flash loan. This is the execution. I can show you guys an actual transaction of this happening. This guy, for example, is using USDC to leverage Ether, okay? Or maybe this is, no, this is the opposite. Actually, the guy was short Ether. Since today the price of ETH was going down, the guy essentially closed the position using the repay with collateral, which used flash loan under the hood, right? So let's try to see what is the sequence of operations here, and let's try to reconstruct the flow. So you can see that the last action is a flash loan because the event is emitted at the end, okay? But it's actually the first action. So the front end tells to the protocol, okay, flash borrow 25,000, almost 26,000 USDC, and send to this contract here. This contract here. This contract is the contract that we wrote that does the actually repay with collateral action, okay? So it takes 26,000 USDC, sends to this contract. This contract takes the USDC, goes to Uniswap and sells for Ether. Then it supplies to the protocol Ether. And then essentially it uses the Ether to repay the flash loan. This is the actual execution of the flow, okay? So I want to go a little bit more in depth in this transaction and actually showing all the steps that are executed during this particular operation. Okay, so I use this tool, guys. If you are just starting with Solidity, or you are more experienced developers, you probably, if you are more experienced developers, you probably know tools that allow you to debug the transaction and to see the actual execution flow of the transaction. This is personally a tool that I love and I use a lot to analyze transactions and debug transaction and actually see the flow of the transaction. It allows you also to see each individual sub-transaction of the interaction with the blockchain. It's really, really powerful. It's called Tenderly. And if you want to experiment for personal use, it's free. So I really, guys, recommend if you want to explore complex transaction or just experiment a little bit with it. It also allows you to simulate transactions in mainnet. So it's really, really powerful. It's really recommended. And more importantly, is free for personal use. So let's see. This is the address that is called the transaction. Let's see if it shows the transaction. This is the transaction hash. I will send maybe in the chat later, or I will add to the document at the end. So when I will share the document, you guys have this transaction if you also want to check. You can see that essentially, like I was saying, the first action that is invoked on the protocol, on the smart contract, that is the lending pool smart contract, is the flash loan, right? So like I was saying, and if we check the parameters of this flash loan, we will see that here the receiver address is the address of the contract that I specified before, that is actually the contract that will execute the operation, and is the 0x63A3F and so on. The asset is the address of the USDC. The amount is the amount of USDC in with the decimals of USDC. USDC has 6 decimals, so it's 25.76K. The mode of the flash loan, it's a particular configuration of AAVE Flash Loan version 2. It has different modes, but there is no time to explain right now. If I will share more documentation at the end, if you guys want to explore a little bit more in depth the AAVE Flash Loan version 2. And there are also other params that these params are essentially used by they are compiled by the front end and passed to the contract that we wrote. And essentially in here, there is mostly the configuration of the swap that we expect to execute, including the path to execute the swap on Uniswap. You know that Uniswap has multiple pools, and usually to get the best rate is not enough to just go and try to swap on one single pool, but you will need to actually tell the Uniswap contracts, specifically the Uniswap router contract, which path across all the pools the trade should take to get the least slippage possible. And this is calculated off chain, right? So our client essentially calculates off chain the path that the Uniswap needs to follow to sell USDC for ETH, right? And so we compile all this information and we pass these as params. All the details are in here. Essentially, it's a series of arrays. I'm not gonna put too much detail on it, but just to give you a heads up on how it works. So back to overview. As you can see, so flash loan is the first action that is actually calling the flash loan function on lending pool. And here, the transfer underline 2 is essentially transferring the funds from the lending pool. To be more precise, in version 2 is from the A token contract of USDC that essentially holds the USDC funds to the caller. If we go here and check the transfer underline 2, Let's check the parameters. You see the target is the address that we saw before. That is the target that actually executes the operation of the flash loan, and the amount is the amount of USDC that we actually defined. The client actually front end defined when called the flash loan. Okay, so this is the actual operation that takes the fund from out of the protocol and transfers to the contract that will actually execute the logic of the flash loan. Let's go a little bit further, and we will see that at some point, here it is, there is the execute operation on lending pool, which actually calls, it is called actually on the, well, let's see if it shows here where it's actually called. This is the execute operation that is called on the contract that I was specifying before. That is the contract that they received the funds. Let's see if it shows the, no, it doesn't show the target, unfortunately. Maybe it shows here. Let's see. No, it doesn't show the target. The target is the address of the contract that we saw before. It's weird because I usually should show. Okay, but it doesn't show. No problem. You will need to trust me that this contract is actually the address of the contract that we saw before, and is the address of the contract that received the funds. Okay, this is called by the lending pool. So once this is called, where is it? Once this is called, the flow of the execution passes on the destination contract, and actually the actual execution of the operation starts. You see that it executes this swap liquidity operation that is actually the operation of swapping the USDC for ETH that we saw before in the list of the transaction. Okay, let's see if at the end I can show here. There is all sorts of operation and calculations done to execute the swap, the withdraw from AAVE version 2, and the redeposit the new currency still in AAVE version 2. Let's see if I can find the actual operation that essentially enables the protocol. Yeah, here it is. At the end of all this huge execution with all the operations and the sub-operations related to swap with Uniswap, withdraw from AAVE and redeposit in AAVE, there is this safe approve that is executed by the contract, and this is safe approve. It should be, I hope is the safe approve that I hope it is. Yeah, this is the address. If you go to mainnet, I will link the contracts afterwards. This is the address of the lending pool contract. So what is happening here is that we are at the end of the execution, and the contract that executed the operation and executed the swap at the end reapproves the lending pool to say, okay, I have done everything I needed to do with my funds. You can take your funds back, and your funds that will be pulled from by the lending pool are the funds sent at the beginning. There are 25.7K more or less, plus a small fee that is the 9 BPS fee that I described before. Okay. Okay, this is the end essentially of the operation that I was describing, and at the end there is a sequence of actions. This is essentially the final part of the flash loan functions, with where all the accounting of the operations is being made. So the state of the lending pool is updated to say, hey, I received a little bit more liquidity, that is the 9 BPS that I have given out before, so I need to account for that particular liquidity, right? So this is all the operations that the lending pool does to actually account for this kind of information, and for the fact that a flash loan was executed and more funds that was taken at the beginning were returned at the end. And that's it. This is the execution. It might seem very, very complex. Under certain aspects it is, but at the end of the day, the code itself is not so, and the logic itself is really simple. It's just taking the liquidity out, using that liquidity to repay the debt or to swap to a certain asset, and then taking that asset and redepositing in other protocol. That's it. It's super, super simple. Okay. Does anyone have questions? Like, Does anyone have any curiosity about this execution flow, and if you guys want to see something in particular? Apparently not. Okay. Okay, then I will go forward. I have 7 minutes left, right?
That's correct.
Okay, perfect. I will show quickly the code that I prepared. I will explain what this code is what is the goal of the code that I wrote, like what is the experiment and what I want you guys to achieve. And then I will be available, of course, on Discord. If you want to contact me on Twitter, I put the handle on the presentation. I also have the same handle in Telegram, so if you guys want to contact me, I will be always available. So let's show quickly the code. Can you guys see my screen with the remix?
Yes.
Okay, perfect. So I recommend you guys, especially if you are beginners, like to use Remix. It's a quick and easy tool to write Solidity code, to experiment with using the built-in JavaScript machine. You can also deploy to testnet, to mainnet. You can call mainnet function. Is really easy to use. Of course, it might be not so suitable for big projects, but it's perfect for code samples and to try out stuff. Okay, so what is the idea and what I built for you guys to experiment with? I built essentially a contract that is the demo Flashroom receiver, that is essentially an implementation of the receiver that I was talking before. And that essentially is the contract that is called using Flashroom and executes the actual Flashroom code, receives the funds and executes the actual Flashroom code. So what this Flashroom receiver do? The idea is that you guys will write the code that goes here, and essentially what should this Flashroom receiver do is calling another contract that I already deployed in mainnet, right? And there is in the GitHub that I prepared, there is the address and all the instructions to call this particular contract. This contract essentially, this one is the fake arbitrage strategy. Essentially is a contract that I wrote to simulate an arbitrage where you use a certain amount of fund and you earn a certain profit, right? It's actually, I called fake arbitrage strategy because it doesn't do any arbitrage. What I did is simply transfer to this contract a small amounts of fund, that is 0.2 ETH. And essentially, when you call this function, passing some ETH, passing some funds to it, it will return the same funds that you sent to the contract plus 9 BPS. That is exactly the amount that you will need to pay the fee. This will essentially allow you guys to execute an actual flash loan successfully and see what it feels like interacting with flash loans. So the core of this contract is the arbitrage function that you guys will need to call. This arbitrage function is a payable function, so it requires that you to work properly. It requires that you guys send some value. You see here, message value. The value needs to be bigger than 0, but at the same time the value needs to be smaller than 0.01 ether. This is a limitation I put to allow everybody to experiment. Otherwise, the contract could be easily drained. So I wanted to put a limit on the amount, so you will receive. You can use maximum 0.01 ETH, and you will receive. When you call this function, the calling contract will receive the amount transferred, so maximum 0.01 ETH plus 9 BPS. You see, guys, I multiply here by 10009 and divide by 10000. So the returning amount will be 9 BPS more than the actual amount that was passed. Okay, this is all that this function do, but it's everything that we need to actually execute a successful flash loan on AAVE. So what you guys will need to do is on the contract demo flash loan receiver that I already prepared, you will need to finish the execute operation here, invoke the arbitrage function on fake arbitrage strategy. This is everything that you will need to do. The flow of actions I already put in the GitHub, but I will repeat here, is essentially getting the reference to the fake arbitrage strategy contract, maybe extracting an interface from the fake arbitrage strategy just to call the arbitrage function. One cool thing is that AAVE uses WETH, that is the wrapped ETH. You will need to unwrap, which is an additional exercise that you will need to do. You will need to use the wrapped ETH contract to call the fake arbitrage strategy, pass the ETH that are being returned, receive the ETH from the fake arbitrage strategy, and rewrap within the contract the ETH received to wrap the ETH, and then approve, using wrapped ETH, approve the lending pool address that is also specified here to be able to withdraw the amount that you received from the fake arbitrage strategy. It's not complex, might seem complex to some of you guys, but it's not complex at all. It just requires a little bit of experiments, and we are at the end, but as I was saying before, there are 0.2 ETH in the contract. I put some safety guards in the contract, but I left on purpose a kind of a backdoor in the contract that if you guys discover, you can empty the contract and take the 0.2 ETH, okay? So this is left for you guys as an exercise and as a bounty so that you are more motivated to try and experiment and actually try to win a small prize at the end. Just one recommendation: if you find the backdoor very quickly, please wait a little bit. I know that like you will get probably front run, but at least like let other guys also experiment with it and don't drain the contracts immediately, just for the benefit of everybody. I think we are out of time, right?
You are out of time, Emilio. You did good though. You did really good doing it in 30 minutes.
I tried. I wanted really to challenge something that is a bit more complex. To be honest, it requires way more than half an hour. But I think that maybe even like if you guys experiment with it, even for more like less experienced Solidity developers, it can be a good challenge, and it also will allow you to understand one of the most famous and infamous DeFi primitives.
For sure. Well, thanks again. It's good seeing you.
Thank you, Joe. And I loved this time with ETHDenver. Hope we can see in person soon.
Yeah, we'll see you soon.
Bye, man. Bye-bye.
Bye.